This conference will now be recorded.
Okay, so guys, so this is our syllabus we have seen from the beginning, and the topics almost I have covered. Just we will quickly go through it so that you guys will remember what are the things we have shown. So basics of database concepts, like we see about what is the purpose of a database, what are the disadvantages of your file systems, all other steps we have seen in this, and introduction to SQL Server. And here in this module, we have seen about RDBMS, Relational Database Management System. What is the purpose of it? Each table is a relation, and Management Studio, how to log into your client, how server client is architected. Then in this module, we saw about the purpose of SQL, the structured query language. This is the language used to communicate between your database and hello Deepak. I'm just going through the syllabus, whatever we saw, so that we are in sync. What are the topics we have covered? It's just a refresher session. So we learned about we learned about databases, and I hope Varun also joined. Varun didn't join. Hold on, let me see. Not sure why he didn't join. That's fine. Let's continue. So we saw about SQL, the purpose of SQL. SQL is a structured query language that is used to query your DBMS database, and it will return the results to your client applications. And we have a DDL statements, DML statements, DDL data definition language, that is to create, alter, modify, drop your tables. DML, you need to manipulation language like insert, all other steps. And you have a DQL, data querying language. It should be coming here. We have covered that one. So these are the different statements we have seen. Then constraints to have data integrity. Constraints, you guys remember, like we had null constraint, not null constraint, unique constraint, primary key, foreign key. So these are the constraints. Check constraint to ensure that the age should not be greater than 18 or any combination. So those kind of constraint to define your data integrity. Then we saw about aggregate functions, sum, average, max. You need to use group by. When you want to aggregate, you need to use group by. And we saw about joins. Joins, in order to get information available in another table, you need to use joins. I'm going to cover this right now. And user security and schemas. So we have created a user, and it is not all the users who logs into the database can access the table. We need to create certain tables, users, and give respective rights to him. So we see like one of the user we have created who has access only to 3 tables. He can able to select. Give me a minute. And we saw about user security and schemas, grouping of objects in a, you can create a schema is nothing but your like a functional area. For human resource, you create one schema, all of the objects you create there, you can map it there. It's like a folder. Then views, we have covered. Views purpose is a virtual table. The data won't be stored there. It's like you can combine multiple tables as a query, then store it there. The data won't be stored there, just a query will be stored. Another purpose of views is to give your security, like people should not access to the tables. Instead, you give multiple tables in a query, then we can access, people can access the view instead of tables. So both the purpose, we use views. We didn't saw about index. So these are the two topics I'm going to cover today, joins and indexing. Yesterday we saw about stored procedures and functions along with the cursors, triggers, all other stuffs. So stored procedures, in order to do certain operations repeatedly, like getting update, you want to create one user, you want to update some information, you pass parameters. Based on that, you will write your logic inside your procedure that will do the respective task. Functions, any calculations. So yesterday we saw deep difference between stored procedure and functions. I'm going to share this PPT, about the PPTs which I have. This contains a syllabus, and another PPT contains some of the key concepts like this. So these are the things we have covered. So today's focus is mainly very good topic, indexes. So any idea before starting index, what is the purpose of index? Here it says how to create all those things. So what is index? What is the purpose of it? Any idea? No idea? Okay, fine. That's okay. I hope everyone is familiar with books while we are reading. If you guys remember this one, index in your books in college, it's the same concept. Like at the end of your book, you will have some index, like working group, which is available in this particular page number. This 4266. If you see 201, 232, 233, 234, if you want to study about active scanning, then you need to go to this particular page, then you can refer that one. Okay, some topics alphabetically it guys arranged, like ad hoc network 206, common use, basic services, something like that. So it's like a searching criteria where your records are stored. So this is the concept behind the index. The same logic applies in your database level as well. So here is the definition. An index is associated with a table or view that speeds up retrieval of rows from a table or view. Okay, it is basically you can create index for a table and rows, which helps you to retrieval very fastly. Okay, that is the purpose of your index. An index contains keys built from one or more columns in the table or view. It is same. You can create index for more than one column. Okay, that is what it mentioned. How it is stored? It's stored in a B tree structure. So forget about this. It will make you complex to understand. Basically, index is used for query retrieval faster. So how it will be fast? Say for example, I'm storing, I want to store customer 1 to 10,000, or now you see Facebook users, all other users, you have millions of users. Okay. So as soon as you log in, you are one in a million. So it has to get your information fastly from that 1 million records. Okay. So how it gets? It should be very quick. Okay, so it has to navigate as soon as sees your name or you sees your password. When you hit that button, it should navigate directly to that particular place where it is stored. So the logic behind this is like this. You assume you have 80 IDs. Okay, now out of that 1 million, this is like that. Now in our example here, you have IDs 80 users, 1 to 80. So 1 to 50, there will be a reference. It is stored in page 1. So here it will go 1 to 50. So here in this page 1, you see like 1 to 10, okay, in page 4. You see the difference over here. The 1 to 9 is in page 4, and from 10 onwards it's in page 5. So it will goes like this. Say for example, ID number 56. Okay, so it will come and search here. Where is 56? 56 is in second page. Second page is here. So 56 is from 55. So 55 is here. So it will navigate to this particular point easily, then fetches the results and gives to you. So this is what index does. Okay. So IDs are stored at the bottom level. So even you create a primary key, okay, so that will create a clustered index where your data are stored at this level, at the bottom level over here. So it will create an index structure like this. Then your data are stored in this last leaf node. Let me show it to you. So this is clear, guys. I think this is very simple. When you have your IDs are nothing but customer ID, login ID, unique values. So those unique values will have a value like this. Then those informations are stored here. Okay. So clustered index. So you have something like IDs stored. So where from A to say for example A to G is stored here. So A to G from Hagdar you have values over here. So this node you have from values from A to G or not from A to G. A to before G. What is that? A B C D E F G H A B C D E F till A to F your values are stored here. From G to is that J, I mean G to J, the values are stored here. From M to R, values are stored here. From S to Z, it is stored here. So you, when someone asks my name Naga, then it will go and check this particular MN. So it will be stored here. Something. So it will navigate this path instead of going searching all the things. Okay. So if the index is not there, what will happen? Okay, it will go and check in each and every record. It will, if my name is Naga, whatever data is stored from the order it is stored. You asked Deepak, I mean, a lot of times how it is fetching, how it is retrieving the data. So this is the answer. When you create an index, it will store in alphabetical order whatever column you have created. The data are stored here. It will be fetched from the page one. This is page one, page two, page three, page four. It is fetched from this order. Okay, always. Okay, when you are not creating an index, it will be inserted random order based on the page availability. If these are concept behind the databases, I mean how it is internally stored. Okay, so when you are not creating an index, the data are stored random order. Whatever there will be like storage concept. Whether the space is available here, then insert it. Whether some space is available, insert it. So if there is no index, Naga can be stored here or any other places. It based on the space availability. That system will decide. There is a huge algorithm behind that. Okay. So again focusing on index. So when you create an index, the data are sorted based on the column you have created index, and it will be stored in the least level. This is your clustered index. Okay, let us stop this one. Before going to non-clustered index, let us focus on clustered index. When you create an index and without an index, how it performs. Okay, so we have data over here. Now when I select this table, I have an index here. Whether index is used now or not, let us see that one. So using execution plan, as I said before, we can see, so clustered index scan. Okay, when you are not using, your index column in your var condition, it will always use a scan. Scan is nothing but the entire table from 1 2 3 4, all the things it will scan and pick up the results. Scan is nothing but row by row, each row it will go and fetch the results. But whereas when I say customer ID, okay, equal to 4, you see the execution plan here, guys. Index scan. I will create a new page. So when I filter using customer ID equal to 4, include execution plan, what it does is clustered index seek. Seek is nothing but your this flow. I've filtered 4. So here it is stored with name. So 4 means Naga, assume like Naga. So it will go in this path M and just pick up the seeking the appropriate value. So difference is here seek, then scan. So when you are not using your index in the where condition, as I said before, indexing is useful only when you are retrieving the value. It is not used for any other purpose. Basically, when you are querying the 10,000 records or 1 million records, the response time should be faster. Okay. So when you create an index, you need to use it in the where condition, then it will be effective. Okay, this is your clustered index. Now let me see if I put instead of 4, when I see instead of index column, I'm not putting the index column in a where condition, I'm putting non-index column Kumar. When I search with Kumar, what it shows? Even I'm not familiar with this thing. Let us see. Definitely it will not do index seek. Let us see. So include execution plan. Okay, see now the first query is using a primary key column, the primary column in the where condition. The second query, customer name in the where condition. First query it is seeking, that is finding the path. The second query it is scan, so there is no use at all. Okay, I mean even you create an index, it is not that you create an index and use other columns in a where condition, that will work out. Whatever column you create in an index, that particular column you need to use explicitly. Okay, then only it will work. Otherwise it is normal. Even some other column, even if you select without this one, it is same. First what it will do now, it will fetch this results first. From this it will pick up Kumar. What this query will do, it will not fetch the results, I mean the all the records first, then it will filter. Instead it will go and check where is this 4 exists. It will pick up only the record, fourth record as a whole. It will be resulting only one input output operation only. This is the thing, guys. So this is about your clustered index. Why? Because your data is stored in the same order. As I said, the clustered index, when you have in a single table, I mean a single table can have only one clustered index, because your data, all the columns, okay, it is not only IDs, your name, address, everything will be stored along with your clustered index in this last leaf node. This is your clustered index. And I said like there are multiple non-clustered index you can create. What is that? So here you have like non-cluster index. It is same example. So say for example Naga, after mn it should be stored here. Maybe we say OTA only. So OTA, means after m, it comes after m, so it will go here, and before s, so it will go here. So OTA, and what happens, this is the leaf node. Here, the data for OTA will not be stored. As we see in this example, the entire row for Akhtar, that is address, phone number, everything is stored here. So easily we can pick up. Instead, what happens for him, it will have one reference for this row ID where the other informations are stored. For OTA, it is 470702. So here 470702. Only the reference is stored. So based on the cluster index, it can say a table can have only a cluster index, A table can have only the non-clustered index. If it is a non-clustered index, data are stored in random order. Okay, I mean, assume there is no index at all in a table. You are creating a non-clustered index. Then while you are inserting, data are stored in a random order only here in this data pages. Then the non-clustered column, it will have that reference where that reference is. So at least when you query with this, it will go and fetch the OTA and the reference number, it will pick it up and show it to you. So somewhat better than your previous, because it is stored for a column. For OTA, it is only 470702. Okay. You can have another non-clustered index. So that particular reference also will point to this row. Say for example, you are creating for a phone number. So this column in this OTA, you will have a phone number. Phone number will have 470702. That will have a same reference. So this is what your non-clustered index. Okay. Let's see how it behaves. Let's create one non-clustered index for a phone number here. Create index non-clustered index. Non-clustered index on. Let us Google it. Forgot about that. The syntax always. SQL Server. Come on. There should be some simple tips. Yes, there you go. There is very big things over here. Okay, create without space. See, these syntaxes are learned very pathetic. Index, I'll put some index name. Okay, test phone number. Phone number on the table name for the column. Okay, the phone number. That's all, I think. Now, what order it should be? We are in some other database. That's why it's throwing error. Okay. Now you see here. See, you cannot see all these things. How it is stored. All of the purpose. Okay. Okay. Now I'm searching using a non-clustered index column. Let us have it is doing a clustered index scan, something new. I mean, if you run this guy, this one returned you the clustered index seek, clustered index scan. Okay, clustered index scan. Whereas here, clustered index scan again. So if you use that one, I mean non-clustered index column, it will give you the clustered index scan only. Okay. So that is the thing, guys. So the main purpose, you got it right. The main purpose behind this clustered index and non-clustered index is that clustered index can be a only one per table, that is using your primary key. If you want it to be a single, I mean a unique identifier for that column, go for clustered key. Then a non-clustered column is like your any frequently used where condition, like address, the location, whichever you want, the multiple columns. Location can be in the customer. Then another thing is like what is his salary. You can have a numeric value also. Usually people will query what is the salary of it, what is the salary range, something like that. And phone number, obviously, even Aadhaar card, multiple you have some addresses. So these kind of things, whichever you use in where condition, so you can have multiple non-clustered index. So this is the core difference between your clustered and non-clustered index. This is about your indexing. Okay guys, now let us see, without, I will drop this index, how to drop this one, and query this one, how it works. Indexes, test phone number, non-clustered, non-unique. I can't drop it. Drop to. See here, everything we can get. Drop index, index on. I think if you have your clustered index on, then using even if you drop it, it results the same. So what I'm saying is, if you have your non-clustered index in place, that alone will give you some differences. If this table contains both your cluster index and non-cluster index, just now we dropped, but we created, okay? But core logic behind this is this one only. I mean, it will have your data stored in separate pages, only the references will be referred here. Okay guys, with this note, I am done. I hope you have got something out of the sessions, the SQL class. Any doubts, guys? Hello?
No, Naga.
Okay, guys. Fine. I hope we have utilized somewhat better in learning SQL. Thanks for participation.
Naga, when there is an application has been created, okay,
Yeah.
and those application data has been stored in the database. So
Yeah.
these index, okay, at which point in time they will create this index after all the completion of application completely
Yeah.
and
Yeah. So basically, when you as soon as you log in or whatever the transaction is going to have, okay. So indexing, basically we have some idea initially. We thought we will be in a position like we will use phone number, Aadhaar number. Based on our assumption, we will create the index. But going forward, okay, after some time, people will ask some other things also, so you can add some more indexes on that. So initially we will, based on our assumption, we will create while creating the database structure itself. Okay. After your, as you asked, after application evolves, after few months, 6 months or 1 year, people will change the application and change the columns also. At that time, if they use those columns, we can amend the indexing, and based on the user queries, we can do that. So it is not the fixed one. Once you have, there is no general rule like you need to create before, you need to create after, something like that. Usually we will create on based on our assumption, these will be the things. But as you asked, the application, whoever queries, in some application they will query phone number, in some application they query the location. Based on the application, it varies. So based on that, we will decide and keep on creating the index, the non-cluster index. But the cluster index, we need to create one.
okay, Naga.
Okay. Fine, guys. I think I'm done. Almost everything covered. We did it in 10 days only. because you guys are not so responding. In case you didn't ask much questions, usually it will be like 2 and 4. When I keep continuing the session, people will stop me and you will ask questions. So that will take some time. But now it is not in this batch. So that's fine. Okay, you can reach out to me anytime. And I would suggest maybe if I can create a form, just give me a feedback. Otherwise, just give me your feedback in WhatsApp. Okay, and try to practice. Otherwise, you can't learn. Definitely, will forget in within few days. Okay. Okay, guys.
Okay, Naga.
Thanks,
Thank you for
Naga.
the training.
Thank you.
Thank you so much. Bye, guys.